And welcome, and in this video we're going to be covering the applications of solving quadratic equations by factoring, okay, or just of quadratic equations, but we will be focusing on using factoring. So this is a very common type of word problem, and I will go ahead and read it to us. So you're asked to install a fence around a cabin, and the cabin has a length of 10 yards and a width of 8 yards. And there's going to be a space of X yards wide between the cabin and the fence on all sides. Basically, the cabin is going to be in the middle. The area to be enclosed by the fence is 224 square yards. Write and solve a quadratic equation. Determine what the dimensions of the fenced area is. Now, this is actually a very common type of problem when we are adding some unknown length to each side and we're asked to find out what that length is. This is very common. Now, let's start by drawing a diagram. So we have this cabin here, and it is 10 yards by 8 yards, right? It's 10 yards by 8 yards. And what we're going to end up doing is we're going to be adding some unknown length around each side that is going to be X yards. We don't know what this is. We do not know what this area or what this length is. But we do know that when we enclose the area is now going to be 224 square yards. Let me finish this drawing real quick. So here is our fence around the cabin. And what you should now notice is that we are adding X twice to kind of each length and width. So this whole side here used to be 10, but we added X to each side of it. So this length here is now 2X plus 10. And we have the exact same thing here. This used to be 8, but we added X to each side of it. So it's now X plus 8, which is 2X plus 8. So we now have some information to go on. They told us that the area is 224 square yards. So I know 224 square yards is equal to the area. And how do we get the area? Well, we do length times width for a rectangle. So that would be 2X plus 10 and 2X plus 8. And now what we would do is we would multiply this out, get everything on one side, and solve by factoring. So I'm going to go ahead and multiply this out. So once we multiply everything out and get everything on one side, we end up here. 4x squared plus 36x minus 144 is equal to 0. Now, this would be a pretty tough one to factor. However, you should notice that there is a greatest common factor of 4. So since this is an equation, you could either factor out the 4, but since it's an equation and a greatest common factor is just a number, I can actually divide each side by that greatest common factor. If the greatest common factor had a variable in it, I would not do that. I would factor out the greatest common factor. But since it's just a number, I can divide each side by 4 and end up getting an equation that's much easier. 0 divided by 4 is 0. 4x squared divided by 4 is 4, or excuse me, is x squared. 36x divided by 4 is 9x. And 144 divided by 4 is 36. So this would end up being our equation. And now this is way easier. We can go ahead and solve this. So when I factor this, this would be 0 is equal to x plus 12 and x minus 3, which gives me x is equal to negative 12 and x is equal to positive 3. And now we have two possible answers, but we actually have to get rid of one of them. X is a length, is some unknown kind of length or space in between the fence and the cabin. Well, that length cannot be negative. It does not make sense for a length to be negative. So what that means is that negative 12 is thrown out, and the only possible answer for X, is X is equal to 3. Now, what that means is that they're adding 3 yards along each side to get the new dimensions of what this fence is going to end up being. And now I can just plug in X to find out exactly what those dimensions are going to end up being. And those dimensions, well, if we added 3 to each side of the length here, that would be 2x plus 10. Well, that just means it's going to be 16 yards for the length. And if I added 3 on each side of the width used to be 8 yards, it would end up being 14 yards. So the dimensions of this fence are now 16 yards by 14 yards wide. And that's just a simple application. This is a very common one. Let's go ahead and take a look at a new problem. Okay, so let's take a look at another problem. So you have to fence in an area of your yard that runs alongside a small river as shown below. And as you can see, my terrible crew drawing, but you can deal with it. So we have this yard, right? It's going alongside a river. Now we have 40 yards of fencing, and we want the area of the fencing region to be 150 square yards as we see here. They want to know what are the possible dimensions. So what are the possible dimensions of this fence? Because there might be more than one. So there's a little bit of information here. I can call this X and this Y. So this would also be X, right? Because it's a rectangle, or we're fencing in a rectangle. Now, there's two things I know. I know that we want the area to be 150 square yards. Well, area is found by, multiplying the length and the width. So I know one of my equations is going to be 150 equal to X times Y. Now, the other part is that we have we have 40 yards of fencing. So that is the perimeter. So if I add these three sides together, now I'm not fencing in this side, right? Because that's going alongside a river, but I'm fencing in these three sides. That is going to be equal to 40 yards because we have a total of 40 yards of fencing. So I know that the perimeter in this particular case is equal to 2x plus y, which is going to be 40 is equal 2x plus y. So we have this equation, we have this kind of system here, and what we can do is actually use something we learned from our last unit, which was systems of equations. We can actually solve for one of the variables in either of these equations and plug it in or substitute it into the other equation. Now, if you solve for a variable in this equation, you're going to end up with something called a rational, because you're going to have a variable in your denominator. Those are a lot trickier to solve. However, if I solve for a variable here, so for example, let's say I solve for y here and get y is equal to 40 minus 2x, that will be pretty easy. That's just a nice linear. And what I could do now is I can take this 40 minus 2x here, and I can substitute that in for y in the other equation. And what that would end up getting us, is 150 is equal to x times y. Well, y we just found out in this particular context is 40 minus 2x. And now what we're going to end up having is a nice quadratic equation. If I distribute this, I get 150 equal to 40x minus 2x squared, and there we go. We have a quadratic equation now. And remember how we solve quadratic equations. We get everything on one side, and we factor and use the zero product property. So let's go ahead and solve this. So I'm actually going to move everything over to the left-hand side of the equation. So I'm going to add 2x squared to each side, and I'm also going to subtract 40x from each side, which is going to end up getting me 2x squared minus 40x plus 150 is equal to 0. And now we can go ahead and factor. And now in this particular problem, there is a greatest common factor that's going to make our lives a lot easier. It's 2. So we can either factor out 2, or because it's just a number. Now, if the greatest common factor had a variable in it, I would not do this. But since it's just a number, the number 2, I can actually divide each side. I can divide each side by the greatest common factor. Now, you could also just factor it out. It won't have any bearing on the problem, but you could do this just to make it a little bit easier. Let me bring it up here. So what this is now going to be is x squared minus 20x plus 75 is equal to 0. And that's a lot easier to factor. Now, if you want to try factoring this on your own, feel free to do so, but I'm going to go ahead and go straight to our factored form. This would end up factoring to x minus 15 and x minus 5. So we get x is equal to 15 and x is equal to 5. And now both of these are positive in this situation, so we actually have two possible answers, and that's going to give us our two possible dimensions, okay? Remember, x represented the length of this rectangle, so there's two possible dimensions. The first possible dimension, well, we could have 15 yards by, and to find the other one, all I gotta do is just like we did with systems of equations, is I can just take these, and I could substitute them in for here to solve for y, and that's going to get me what my other variable is going to be. So if I substitute 15 in here, that would be 40 minus 30, which is 10. So one possibility would be 15 yards by 10 yards. So that would be one possibility. And the second possibility would be, well, if the length was 5 yards, so let's say each of these were just 5 yards, and then I would substitute that in here, that'd be 40 minus 10, so that would end up getting me 30. So one possibility would be to have a dimension of a fence of dimensions 15 yards by 10 yards, and the other possibility would be a fence with dimensions 5 yards by 30 yards. So really wide one. This one's a little bit more uniform. And that is it. That is solving quadratic, or that is applications of quadratic equations and factoring. Now you could change this slightly to be an inequality problem, like have an area of at least 150 square yards. You could have something along those lines. Just make sure that you're reading into the problem carefully and solving it appropriately, okay? I hope this video was helpful. If there's any questions, please feel free to let me know, and I look forward to seeing you guys in the next video.